Hello everyone, Deepak this side, and today my topic is BGP, which means Border Gateway Protocol. So let's start the theory portion. So very first question, what is BGP? Let me take a laser. Okay. So what is BGP? BGP is a path vector routing protocol used to route traffic from one autonomous system to another autonomous system. It also known as the exterior gateway protocol. Autonomous system number is a 16-bit number ranging from 1 to 65, 535. And there are some specific subnets range which start from 64, 512 to 65, 535. And these are reserved for the private use. Means we can use this ACE number for our internal use. BGP is a application layer protocol which uses the TCP for reliability and the port number is 179. So it is very important to remember this TCP port number 179 because it helps to troubleshoot the BGP in case if everything is configured properly, BGP configuration is okay, and though if the neighborship not coming up, we need to check whether is there any ACL apply. Maybe that ACL is not allowing the 179 port. So this is very important port number to troubleshoot the BGP. Designed to scale huge internetwork like a internet. So this BGP is the only protocol which currently working in industry to connect the different AS numbers. It sends updates to manually defined neighbors as a unicast. In the metric BGP use, that is attributes. These are the we will discuss on it. What are the attributes BGP use to calculate the matrix? And the metric is the value which defined, which is the metric is the deciding factor which path is better. Like in EIGRP, we are having a k values to define the matrix, and in OSPF we are having a bandwidth. In similar BGP we are having attributes. So what actually this path vector means? So path vector is basically it helps any AS or any router to understand if the any network is learning. So this network is coming from how many AS far. So if we take an example, here you can see the 20 network is a part of 65 400 network. Okay, when this AS advertise this network, and this network when reach to the AS 65 100, so this router has the complete visibility of this route, like from where this route been learned. So it get to know, like, okay, it is coming from 65 200, and before that it was coming from 65 300 and 65 400. So this is how this router has complete visibility of this network. So that's why we call it path vector. Split horizon rule in BGP. So split horizon is a technique to prevent network for from the loop. So there are two concepts behind it. Very first is if there are IBGP neighbors in BGP, so one IBGP neighbor cannot forward the learn route to the next IBGP neighbor. And the second loop avoidance technical technique is the AS number. Suppose as we all know, like all the AS are internally connected with each other, because we all are in internet, everything are internally connected. So there is a very high chance, like the route which one AS is advertising, maybe that can be come back to that same AS number, to same AS. For example, suppose this AS is advertising 20 network, and it's been advertised to next AS, and then next AS, then next AS. And when this AS 65 100, when this AS will advertise this network to the AS 65 400 again. So when this router 65 400 receive this route from the AS 100, it will check how many AS it crossing. So when it checks, it will find its own AS number tagged there, like 65 400, 65 400. Can you see? Because it is coming from the 65 100, 65 200, 65 300, which is 65 100, 200, 300, and 65 400, which is its own AS number. So when it see its own AS number tagged in, it will simply discard this update. It will not register this route into its routing table. Okay, so these, there are two loop avoidance in BGP. One, it based on AS number. If it is find see its own AS number, it will not learn that route. And second, one IBGP will never share the learn route to the next IBGP neighbor. And let's what are the neighbors in BGP? So basically there are two neighbors in BGP. One is IBGP and EBGP. IBGP, the neighbor which is part of the same AS, that will form the IBGP neighborship, and the neighborship between the two different AS, they will form a EBGP neighbor. So BGP neighbors are router forming TCP connection for exchanging the BGP updates, also called as a BGP peer or BGP speakers. There are two type of BGP neighbors relationship: IBGP and EBGP. IBGP means same, both neighbors are the same AS, and EBGP when both are belongs to different AS number. BGP neighbor adjacency, it states, just like OSPF or EIGRP, BGP establish a neighbor's adjacency with other BGP router before they exchange any routing information. These neighbors have to be configured manually. There are total 6 different BGP neighbor states. So very first state in BGP is a idle state. So the first state where the BGP wait for the start event. The start event occurs when someone configure a new BGP neighbor, or when we reset and establish BGP peering. After the start event, BGP will initialize some resources, resets the connect retry timer, and initiate a TCP connection to the remote BGP neighbor. It will also start listening for the connection in case of remote BGP neighbor tries to establish a connection. When successful, BGP will move to the next state, which is connect state. If it is fail, then it will again then it will be remain in a idle state. So the second state is a connect state, where BGP is waiting for the TCP three-way handshake to be complete. When it is successful, it will move to the third state, which is open send state. In case it fails, it will continue to the active state. If a connect retry timer expire, then we will remain in this state, and connect retry timer will be reset, and BGP will try a new TCP three-way handshake. If anything else has happened, for example resetting BGP, then we will move back to the idle state. So connect state, BGP, so we know connect state we will reach when we are, in case it is failed in a second state. Okay, in connect state, if it is failed, then it will go to the active state. Okay, so what happened in active state? Here in active state, BGP will try another TCP three-way handshake to establish the connection with the remote BGP neighbor. If it is successful, it will move to the open sent state. If connect retry timer expires, then it will move back to the connect state. BGP will also keep listening for the incoming connection in case the remote BGP neighbor fails tries to establish a connection. Other event can also cause router to go back to the idle state, like resetting a BGP, for example. Okay. Fourth state is a open sent state. Uh, in this state, BGP will be waiting for the open message from the remote BGP neighbor. The open message will be checked for errors. If something is wrong, like incorrect version number or wrong AS number, like incorrect version number, right now BGP using the version 4. If that is a wrong configure on remote peer, uh, BGP peer, then that will not be go further. That will be down. Or if the wrong AS number is configured, in that case as well, it will not form a BGP. Then BGP will respond with the notification message and jump back to the idle state. This is also the moment where the BGP device decides whether to use eBGP or iBGP, since we are checking the AS number. So if the same AS number, then iBGP. If it is that different AS number, then eBGP. If everything is okay, then BGP starts sending the keep alive message and reset its keep alive timer. At this moment, the whole timer whole time is negotiated. The lowest value is picked between the two BGP routers. In case TCP session fails, BGP will jump back to the active state. When any other error occurs, like expiration of a whole timer, BGP will send the notification message with the error code and jump back to the idle state. In case someone reset the BGP process, we also jump back to the idle state. This is the fifth state, where BGP wait for keep alive message from the remote BGP neighbor. When we receive the keep alive, we can move to the established state, and neighbor adjacency will be completed. When this occur, it will reset the whole timer. If we receive any notification message, like if any fatal error occur, the remote BGP neighbor, then we then from the remote BGP neighbor, then we will fall back to the idle state. BGP will keep sending the keep alive messages. Established state, the BGP neighbor adjacency is complete, and this is the last and final state. Like when we get the uh, open message, open confirmation message from the neighbor. Okay, then after in established state, BGP router will send the update packet to the exchange routing to exchange the routing information. Every time we receive a keep alive or update message, the hold down timer will be resetted. In case we receive a notification message, we will jump back to the idle state. So these are the six states of BGP, and this is the table which help us to understand. Like first we will start from the idle state, when where we will configure the BGP. In connect state, they will try to form a TCP connection, and if it is if it TCP connection successful, it will send the open send message, and uh, uh, and later it will wait for the open confirmation message. Once it receive the confirmation message, they will jump to the established state, where they will uh, exchange the routes. Okay, in open confirm, like it's a keep alive message. If in connect state, if it is like getting any if TCP is failed, then it will jump to the active state. In active state, it will try again to form the TCP. If it is passed, then it will go to the open send. Okay, and if it is again the retry timer is expire in active state, it will again go back to the connect state, and there it will again start the TCP connection. So this process will be keep going, and if there is any fatal error occurs, so it will jump back to the idle state. Okay, if any fatal error occurs, it will send the notification message as well. BGP messages, so there are total four messages. Very first message is the open message. It contains the several parameters, like BGP version must be same between the BGP peers, local AS number, and BGP router ID. Second message is the keep alive messages. This message is sent periodically every 60 seconds by default, to ensure that the remote peer is still alive, available. If router does not receive a keep alive from peer for a whole time period, which is by default 180 seconds, then router will declare the peer as a dead. The third message is the update message. This message used to exchange the route between the peers. Last is the notification message. This message sent when there is a fatal error condition. If a notification message is sent, the BGP peer session is turned down, and reset. Here are the BGP attributes and path selection mechanism. So these are the total 11 attributes which helps to decide the better path. We will cover one by one. So let's start with the weight. Weight, it tell us how to exit the AS. This weight attribute help us to tell us how to exit the AS, and the path with the higher weight will be more desirable. It's local to the router, means it will not advertise to the other routers in the same AS. And default weight value for the directly connected route is 32,768, and for LAN route it is 0. For example, here router C, okay, and there is the network 10. With how can we use this weight? Okay, suppose uh, in my organization, I'm having a two connection, one ISP connection and two ISP2. So ISP1, I am having a higher bandwidth, and I want every incoming traffic should be, or and sorry, all the outgoing traffic should be uh, go from the ISP1, and only if this ISP1 went down, use the ISP2. So what I can do, I can use the weight attribute. In this case, I can just configure higher weight value with the ISP1 remote neighbor. So every time, if any means if router C want to go to the 10 network, it will not use this ISP2, it will always forward that packet from the ISP1 with the help of weight. And like you can see, uh, here the 10 network which I am defining. And but this weight, there is a one drawback, like this weight attribute, the this attribute cannot be shared with the another IBGP neighbor. Suppose if I increase weight on router A, and I am having, suppose, two edge router A and B, and two different ISP terminating on each one of it. Okay, and I want every all the my network traffic should go out from the ISP1. To achieve that, if I use the weight on router A, so whenever router A wants to go to the network 10, it will always forward the packet from the ISP1. But what about router C and router B? Because this is non advertise attribute, so router A, when advertise this 10 network to the router reflector route, it will not add that weight value on that route. So when the router C receive uh, about the network 10, so it will receive a router 10 update from the ISP2 and from ISP1 as well. But when router C check to reach 10 network, I'm getting a shorter path via router B. So it will never forward the packet to the router A, because it has no idea about the weight, because weight is the attribute which cannot be sent to the next router. So that's why this attribute has some drawbacks. And so to overcome this, we are coming with the different attribute, that is local preference. And the second drawback of this weight is it's a Cisco proprietary protocol. Sorry, it's a Cisco proprietary attribute. Okay, if you are having a non Cisco device, this attribute will not be work, you will not get this option. So the second attribute is the local preference. This attribute also define how data traffic should be exit the AS. Path with higher preference value will be more desirable. It is advertised only to IBGP within the AS. The default value is 100. So the local preference value, yes, this attribute values can be shared to the internal or IBGP neighbors, but not to the EBGP. So yes, if we are having the same scenario, like two edge router and two different ISPs are terminating, and we want all the outgoing traffic should go from via ISP1, that we can achieve with the help of local preference. So for that, what I will do, I will go into a router A and configure the local preference value with the ISP1 remote neighbor. For that, you can see the configuration here. I am going router A, inside the router A, and putting IP prefix list, and defining my interesting network, that is 10 10 10, and then creating a route map with name of pref and permit 10, match the IP address prefix list, that is network 10, and setting a local preference value is 400, and then going inside the BGP configuration with the neighbor, this xxx means whatever the IP is configured here, that IP, and route map prefix in inside. This configuration is saying whenever router A receive 10 network in direction, so apply the local preference value 400. So when this 10 network will come via ISP1 to the router A will add the local preference value 400, and that will advertise to the route reflector. And route reflector, there is a properties that route reflector can share one IBGP route to the other IBGP route. Okay, so it will exchange. So router reflector will learn this 10 network from the both router A and B. A with the local preference value 400, from B without local preference value. So router C will exchange, will send router B route to the A, and router A learn route to the B. So uh, it will also make uh, to reach to the 10 network better part via A, because in uh, the 10 network which is learning from the router A having a local preference value 400, so that will become a more desirable. And the route which are learning from the router B, though it having a lower AS number, but for router C will become a best part via router A, because uh, local preference value is having a higher means that checks before the AS number, that get checks before the AS number. So every time router C want to go to the 10 network, it will send the packet to the router A. Even router B, whenever it has to send reach to the router 10, sorry, network 10, it will not because it is directly run from the ISP2, but it will not directly send the packet. It will send this packet to the router A. So router via router A, it will reach to the 10. Okay, so this is how we can manipulate the outgoing traffic with the help of local preference. Then the third attribute is the origin. Prefer the path that is local to router directly connected. In BGP table, you will see the next hop 000. You can get the path in BGP table through the BGP network command aggregation or redistribution. A BGP router will prefer the route that is installed into a BGP itself over the route that another router installed in BGP. So it's simply meaning that in originate is the third attribute, and it will prefer the route which is directly connected and which is locally originated by the router, not the route which is being learned by the external routers. Okay, suppose if one router and having a 10 network which is directly connected, the same type of network prefix, it is learning from the redistribution command and all. So it will never it will prefer the locally connected or advertised network, not the redistributed network. Fourth attribute is AS path. AS path is the well-known and mandatory attribute. Means this attribute will send to the next EBGP, and it will advertise to the all the different AS number, AS as well. So AS path is the well-known and mandatory attributes. So the a list of AS number through which update has been traveled. A path with the shortest AS path list will be the more desirable. Okay, if any route is learning from suppose how BGP decide which is best, because we have discussed this in earlier slide. Whenever any route get learn on BGP router, it have a complete visibility of that network, like how many hop away this route get learned. So if BGP having two ways to reach any one network, so it will compare from which direction I am getting the lowest uh, AS path numbers. That that path will become the best. Suppose here the uh, one example, like here the 10 network, okay. So when the AS 65300, when it will receive the same 10 network from the two direction. One is from directly, and one is from the longer path. So if it will check its routing table, so it will see the 10 network I am getting directly from the 65 100, okay. And same network I am also being learned from the 65 400, 65 200, and 65 100. And this AS path length is bigger. The shorter AS path always the desire, so this shorter path will become the best. So this is the fourth attribute. And this attribute also help, to control our incoming traffic. So we can manipulate our incoming traffic. For example, I am having my organization, okay, here. And suppose I am running one data center, and inside the data center having one server with that 10 network. What my organization requirement, all the public traffic should be to access my server, they should all come via ISP1, not from ISP2. To achieve this, what I can perform, I can make this best incoming route. I will prepend more AS path on it. So when I'm advertising this 10 network to the ISP2, I will prepend more AS number. So for every time when AS check to reach to the 10 network, it will find more hop counts to reach to the 10 network. So for router B to reach 10 network, route router C will become a best path. How can we achieve it? Let me explain. For that, we can create again the local preference and our interesting traffic 10 10 10. Create a one route map, like prepend, I have given name, and permit 10. Match IP address prefixes network 10. I'm calling this network here. Now set a this is the command, set AS path prepend and 65 300 65 300. Then go to the router BGP 65 300 here, router A, and with the neighbor 192.168.2.2, which is this one, okay. Remote AS 65 100, neighbor uh, the same 192.168.2.2, route map prepend. We are calling this route map into out direction. So it this mean is it's saying whenever I'm advertising 10 network to the to the neighbor 192.168.2.2, whenever I'm sharing this 10 prefix, prepend the AS path, okay, uh, AS number two times. So whenever router B receive the route, so it will looks like something this. So router 10 10 10, it will receiving the you can see 65 300 65 300 65 300 three times. It's seeing, router B is seeing three times, three hops away to reach 10, but it is getting the same route from the 65 300 as well, 65 200 as well, via router C. So for router B to reach 10 network, this via router C become the best path. So this is how we can manipulate our incoming traffic. The fifth attribute is a origin code. This is the code which you will see when you check for the show IP BGP route. So at the last you will see whether it is I or it's a question mark, okay, where I indicates advertised in BGP using the network command. EBG, EGP or small e redistributed from the EGP, which is the older version of BGP. You will not see this code because it's now obsolete. And incomplete, which indicate by question mark. And this is a redistributed route into a BGP from the IGP like a OSPF, EIGRP, or from the static route. And in this all three code, the best the preferred route is a I, and then E at last question mark, the redistributed. For an example, if I try to show you, like you can see these codes are mentioned here at the last question mark here. The med value, this is med can also used to advertise to your neighbor how they should enter your AS number. Okay, this is also like your AS path prepend. Okay, but the difference between the AS path attribute and med, like this med attribute is only shared to the next EBGP neighbor, and this EBGP neighbor cannot share this med attribute value to the next EBGP. But in AS path attribute, that AS path attribute value will be advertise whole AS uh, advertisement, means that will be sent to the every EBGP router, but med value only to the next adjacent neighbor only. So med is exchanged between the autonomous system, and the path with the lowest med will be more preferred. For example, here again we are having a 10 network, okay, 10 network server in our organization, and what we want from outside, if anyone is coming or trying to access the 10 network, they always prefer the ISP1 connection. So what I will do, from one edge router to the next, this will be possible when we are having a such kind of connection, like we are having a two edge router, and these both edge router is connected with the one uh, ISP router, ISP edge router, then only this thing will work. For that, what we will do, from one end we will advertise lower med value, and from other edge router we will advertise a higher med value to the uh, ISP router. So whenever any traffic coming from that ISP to our uh, to our enterprise, this ISP always forward that packet via lower med value, which is ISP1. That this is simple. Okay, and the seventh attribute is EBGP path over the IBGP path. Yes, definitely, if we are learning, or if all six attributes are tie, and if we come to the seventh attribute, then definitely it will check whether the route learning it's coming the route is being learned by the EBGP or IBGP. Then it will always prefer the EBGP, because EBGP having a lower AD value, which is 20. And for other IBGP, if we talk about the EIGRP, we are having the 90. For OSPF, it is 110, and for RIP is 120. So definitely the lower AD will be become a more preferred. That's why EBGP will be preferred. Eighth attribute is a shortest IGP path to BGP next hop, and this is says prefer the path within the autonomous system with the lowest IGP metric to BGP next hop. It means that because we all know BGP is a overlay protocol which run over the IGP protocol. So within the same AS number, within the same AS, the IGP protocol prefer or they become they means they are the best option to select the path, because they are having a lower AD value than the IBGP protocol. IBGP protocol, because within the same AS, IBGP neighbors are there, and they are having a AD value 200. So definitely that will be not a good option to consider for a path selection. That's why we check whatever IGP protocol with the lower metric value to reach to the next BGP hop will be considered as a best path. And the ninth attribute is oldest path. So whatever path was learned or received first, that will be considered as the best if the all eight attributes are tied. Then the 10th attribute is the router ID. Prefer the path with the lowest BGP, neighbor router ID. The router ID is based on highest IP address. If you have a loopback interface, then IP address on a loopback will be used. The router ID can also be manually configured. Suppose if all the nine attributes are tied, then the tiebreaker will be become a router ID. So if you look here some scenario, like router A, like if all nine attributes are tied, it will check to in both neighbor, which neighbor having a lower router ID. If you'll see, it's a 111 and it's 111.2. So this one is having a lower router ID. So router A always send the traffic via lower router ID. And the last attribute, the tiebreaker of BGP is neighbor IP address. Prefer the path with the lowest neighbor IP address. If you have a two eBGP router and two links in between, then router ID will be the same. In this case, the neighbor IP address will be a tiebreaker. Yeah, suppose this are edge routers and these are connected with the single uh, ISP edge router. So in this case, if we check, the router ID is same. Okay, that the router ID will be same for both. So the last tiebreaker will be a neighbor IP address. So whichever having a lower network interface IP, that will become a preferred path. In this case, you can see 192.168.1.2 and 192.168.1.1. So 1.1 is a smaller, so this path will become a preferred path. To remember these attributes, we have shortcut, like you can remember in this way: n valla omni, where uh, n means next hop, w wait, l for local preference, locally originate and as path, then origin code, med value, neighbor type, and ibgp metric to next hop. So this is how you can remember attributes. Thank you guys for being with me.